at a few examples that solve systems of equations graphically. So remember, by systems of equations, we're looking at two equations and trying to figure out where do they intersect. At what x and y value is it the same on both equations? So our first equation is y equals negative x minus 3. So in this equation, my slope is negative 1. My y-intercept is negative 3. So I'm going to start at negative 3. Then I'm going to go down 1 to the right 1, put another dot, connect those to make my line. My next equation is y equals x plus 1. My slope is 1. My y-intercept is also 1. So I'm going to start at 1 and go up 1 and to the right 1, connect those dots to make my line. And you'll notice there's a point where that purple dot is that intersects those two lines. Therefore, my answer is negative 2, negative 1. I've got y equals negative 5/3 x plus 3. My slope here is negative 5/3. My y-intercept is at 3. So I'm going to start at 3, and I'm going to go down 1 to the right, down 5 to the right 3. Connect these points to make my line. My next equation is y equals 1/3 x minus 3. So my slope is 1/3. My y-intercept is at negative 3. So starting at negative 3, I'm going to go up 1 and to the right 3, connect these lines to make my point. You'll notice a point of intersection, which is at 3, negative 2. So that is my solution to my system. One more example here, y equals x minus 2. My slope is 1, the invisible number next to x, my coefficient. My y-intercept is at negative 2. So starting at negative 2, I'm going to go up 1 over 1, connect those to make my line. My next equation is y equals x plus 1. So my slope again is 1. My y-intercept is also at 1. So starting at 1, I'm going to go up 1 over 1, connect these lines to make a point, or these points to make a line. And you'll notice these lines are parallel, which means they are never going to intersect, which means there's actually no solution to this system. So when you have the same slopes, you're going to have a no solution. All right, in our last example here, we're going to determine if an ordered pair is a solution. So say it's giving you an answer and asking you, does this work? So my first ordered pair is 5, 10. So what I need to do is to substitute these coordinates in for x and y, and it has to work on both equations. So let's start with my first equation. So I'm going to substitute 5 in for x and 10 in for y. So I have negative 3 times 5 plus 2 times 10, and that needs to equal 5. So again, I took these values and plugged it into this equation. So negative 3 times 5 is 15, plus 2 times 10, which is 20. And when you solve that, you get 5 equals 5. So this is true. So far it works for my first equation. Now I'm going to substitute it into my next equation. So now I'm going to use the same xy values, but I'm going to plug it into this equation here. So I've got 10, since that was my y, equals negative 4 times 5 minus 3. So again, I just substituted in the x and the y. Simplify this, you get negative 10 equals negative 20 minus 3. So I get negative 10 equals negative 23, which is not true. Therefore, 5, 10 is not a solution to the system of equation. So let's try another set of coordinates. What about negative 1, 1? So again, I'm going to take these xy values and plug them into each equation. So my first equation, I'd end up with negative 3 times negative 1 plus 2 times 1 to see if that equals 5. When I substitute it in and simplify, I get 3 plus 2 equals 5, which is 5 equals 5. That works. So now let's try the second equation to see if this is a solution. So again, I'm going to use the same coordinates, negative 1 and 1, substitute those in for x and y, simplify it, and I get 1 equals 1. So since it works for both equations, negative 1, 1 is a solution to the system of equation. So just remember, you substitute those numbers in for x and y, and as long as it works for both, it is a solution.